Graphing a line given its equation in standard form. For this topic, you have choices on how you go about solving these problems. I would say when you have an equation in standard form, so standard form means that you have the x and the y both on the left-hand side, that it's a little easier to just find the x and y intercepts and plot the x and y intercepts and then connect the dots to form a line. So you have that option. Your other option is to put it into y equals mx plus b format. So you could take this equation and you could add 3x to both sides. And then you would have y equals 3x plus 3, and you could plot this using y equals mx plus b, so using slope and y-intercept. However, I think I'm going to go about this with the x and y-intercept method because it's a little faster. So to find the x-intercept, that's when y is equal to 0. So if you plug in 0 for y, you have 0 minus 3x equals 3. The 0 is not really doing anything. Really, all you have is negative 3x equals 3. Divide by negative 3. And you're going to get that the x-intercept is negative 1. So if I come over to my graph and I go on the x-axis to negative 1, so I'm on the x-axis because it's my x-intercept, I'm plotting a point at negative 1. Now if you've watched a previous video of mine on x-intercepts and y-intercepts, you know that I like to do this a little faster. So since with an x-intercept you plug in y equals 0 and with a y-intercept you plug in x equals 0, all that ends up happening is you end up destroying, for the x-intercept you end up destroying the y, right? So if you look right here, this is just the same equation as the y being gone. And with the y-intercept, it's the same as just destroying the x. So I'm not going to take the time to actually plug in the 0 for x because it would just disappear once I did that. So if I had this equation and I just got rid of the x part, it would be as if that didn't exist. And I get y equals 3 for the y-intercept. So it's as easy as that. The y-intercept is at 3. So on the y-axis, I'm plotting a point at 3. And now I have 2 points. I can connect them together and I have a line. So let's try it with another one. So we have x minus y equals 2. Let's do the x and y-intercepts again. For the x-intercept, I'm ignoring the y part, so I just get x equals 2. So on the x-axis, I come over here to 2 and I plot a point. For the y-intercept, ignoring the x, I have negative y equals 2. This is the same as negative 1y, so when there's not a number written in front, it's the same as having a 1 in front. So a negative y is the same as negative 1y. I need to divide by negative 1 on both sides. Then I'll have y equals 2 divided by negative 1 is negative 2. So the y-intercept is at negative 2. So on the y-axis, I come down to negative 2. From here, just connect the dots. Okay, let's do one last one. Once again, finding the x-intercept and then the y-intercept. So with the x-intercept, you're ignoring the y part. So I have negative 3x equals negative 6, and now I can solve for x. Dividing by negative 3. Negative 6 divided by negative 3 is positive 2. So there's an x-intercept at 2. So on the x-axis, I come over to 2 and I plot a point. For the y-intercept, I'm ignoring the x part. And if I do that, I just get y equals negative 6 because there's nothing in front of the y for us to divide. So the y-intercept is at negative 6. On the y-axis, I come down here to negative 6, plot a point. and connect my lines. And that's that. So once again, easiest with this one to just find your X and Y intercepts, plot both those points, and connect the points together with a line. All right, hope you're having a great day. Keep on doing what you're doing. You're doing great.